Hello YouTube, on this side. So this video is kind of continuation of my KEDA autoscaling with Prometheus KEDA. In my previous video, I tried to explain how we can autoscale pods based on Prometheus queries, aka PromQL. So in this video, I'm just going one step further by adding Grafana in the cluster. So if you're not aware of Grafana, so Grafana is a open source tool which is usually used with Prometheus. So why what is Grafana and why it is used with Prometheus? So Grafana is basically used to create beautiful and attractive dashboard of the matrix which is collected by a Prometheus server. So in my previous video or maybe in any videos you have seen Prometheus, so you are already aware that to get or to fetch data from our nodes, we have to pass or to write some PromQL or Prometheus queries to get the raw data inside our Kubernetes cluster, which is also been able to get using Node Exporter. So sometimes the developers or the team, the monitoring team, which are not aware how to write Prometheus queries, uh, for them, learning Prometheus queries or PromQL is a different task or a new task. So to make things easier, uh, for them, Grafana is built or Grafana is there. So using that, uh, so using Grafana, they can easily create dashboards according to their needs, which they always wanted to monitor, and they can monitor anything. They can monitor any kind of resource or anything which is running inside the Kubernetes cluster, and every and each detail of the nodes. So we can also use Grafana with other tool as well. But in my this demonstration, I will be using Prometheus because we will be uh, using KEDA Prometheus Scaler uh, to autoscale our application or the pods. So in my last video, I have already gone through like how Prometheus scaler work with KEDA. So you can easily uh, check that. And in this same video as well, I will be like replicating the same step. So you can also check this video fully so that you don't have to check that video as well. It's totally up to you. So let us directly jump to the demonstration part. So directly going to the demonstration part, let me introduce let me tell you that which repository I'm using here. So I'm using the same repository, same branch, which I have used in my Prometheus video, Prometheus Scalar video. Only thing I have changed is my shell script file. So in this shell script file, I just have added the respective comments for the commands I'm using and the helm step to install and configure Grafana inside our cluster. And in the last step, I have also added Grafana admin password because it is required when you will be accessing the web application of Grafana or the homepage of Grafana. Nothing is different from that video, so yeah, you can directly use this. Okay, so let me first clone this repository, kubectl, edit, oh sorry, okay, git clone -b prom. Let us move inside this folder. Okay, so let us change the mode of my shell script, make it executable, and let it run. Okay, dot slash install So this shell script does nothing. It will automatically install. Not automatically means I have added the commands to install KEDA, Prometheus, and Grafana. And this is the password. Okay. So let me uh, let me use another tab for other operations. So let me move inside this repository directory. Okay. So first step is done. So let me check if everything is up or running. Up and running. kubectl get all hyphen hyphen all minus name spaces. Okay. So yeah, I think mostly the things are running. Okay. So to access Grafana web application or the server, we have to make its service type to node port, and the Grafana and everything which is related to Grafana is running on inside Grafana namespace. So let us edit this kubectl edit service Grafana hyphen -f Grafana. So to change the things related to service type, we just have to edit this YAML manifest file and make it to node port, and now it will assign node port to the service. Okay, so yeah, so the port is 32752. Open this traffic ports, access this. So this is the beautiful login page of Grafana. So the email is, or the username is admin, and the password, it was stored in tab 1. Yeah, this is the one. Enter this. See, so we are inside Grafana homepage. So to make things in flow, first we have to create a dashboard. So creating a dashboard is easy. Just click on create dashboard, add visualization. Okay, so if you are also stuck here and you are confused like how we have to configure data source. So configuring a data source is nothing but giving it or providing the data, the source from which Grafana should fetch data and create bar graph and other stuff accordingly. So to configure a new data source, we will just click on this. This is select Prometheus because we are using Prometheus. Name, let it be Prometheus, and here. So here we have to pass Prometheus over URL. And currently everything is running inside the Kubernetes cluster because every service is cluster IP. So what we have to do is we just have to go back to our terminal, tab 2, and let us check Prometheus server service. Okay, so this is the service. We have to again modify or use node port for this service to get access outside the world. kubectl edit service hyphen add monitoring because it's inside this namespace. Okay, okay, edit this node port. I think edited successfully, and yeah, this is the port which is 30718. Let us access this. So here you can see our Prometheus service is also up and it's correctly configured. Okay, so now the thing is we have to pass or to enter the Prometheus server URL. So for that, what we can do is we can do the things. So let us first uh, grab how many nodes are working and what are their IPs. Okay, sorry, kubectl get nodes. So here you can see we are using control plane and node 01, and these are their respective IPs. Okay, let us check what all uh, nodes are monitoring namespace is using. So let us check kubectl get all hyphen n monitoring uh, hyphen o wide. Okay, is this okay? Let me do this first. Okay. Prometheus, it's running. Okay, I think hyphen o wide is fine. Hmm. So pod, I can see. Okay. So yeah, the pod is also running on node 01. So what we have to do is we just have to fetch our node 01 IP like this and HTTP this, and we have to assign the port of our server, and our server is running in this port. Okay, so this is the Prometheus server URL. If you are not confident enough or you are not sure like the URL you have entered is correct or not, then you just have to simply click on save and test. If it is passing you this message like successfully queried Prometheus API, so you are 100% correct and you have configured it correctly, like I have done. Okay, so this is dashboard, and if I will click on add visualization, and here see the Prometheus data sources visible to us to select. So here you can see these are the form of chart you can use to monitor your data. I'm not sure like which data currently it's monitoring or which query it's running. So let it be. So our first step is done. We have successfully configured Grafana and Prometheus inside our cluster, and both of them are in sync. So now let us deploy our application as well. So I'm just using the same application which I've used in my previous demo video as well. So let us apply this as well. And everything of this application is running in default namespace, so no namespace is required to create for this. Let us check the pods. Okay, pod is also running. kubectl get service as well. Okay, so for this application, I have to run my service, means I'm just forwarding the port of my service. So for that, I will be using uh, this command, and the application is using 3000 port. So this port, let us use this port only for port forwarding. Okay, create a new tab. Okay, let us curl our application, which is on localhost 3000. So it should pass the message hello world. Okay, so our application is also correctly deployed and the service is also up. So our second step is also done. Now the third step is first we have to move inside this and deploy this scaled object YAML. So in the scaled object YAML also I have not done anything. I'm just using the same YAML manifest file which I have used in my Prometheus scalar video. So we'll simply apply this as well. And if you just want to like know like what I've written inside this, you can also check my GitHub repo, or you can definitely check the video. I have tried my best to explain how KEDA is using Prometheus scalar, and what all the things and what all the fields are required to make the things executable. Okay, so this is also applied and created. Let us check kubectl get scaled object. So here you can see we are getting the data. So yeah, it's correct. So our third step is also done. Okay. So let us check if we are able to create some dashboard or not. So let us add a query. To be frank with you all, I don't have much knowledge on Grafana. I just have small or like enough knowledge like how to set up the things for our data sources and the queries, which is already there written by the developers or by other teammates. So you can definitely check Prometheus and Grafana videos on YouTube. There are plenty of playlists with amazing explanation and demonstration video. So this is the metric which we have to check. Hello world request, label is service, and the service name is demo KEDA SVC. So it has automatically provided us the thing. We don't have to write anything here. Just run query and let me do this stat as well. Yeah. So this is beautiful because we have curl our service one time. So it's correctly showing us the value. We can also check the same using this query written inside this and like this. I guess this will be fine in our Prometheus. Yeah, execute. So see one. Mm, if I, yeah, one. Okay, so here you can see that both of the things are sync, and they are getting the correct data from Kubernetes cluster. They are not in they are not shuffling the things. Okay, so our third step is also done. Now let us try to simulate some fake traffic or some fake web request for application the service. So for that, I will be installing Hey. It's a simple command line utility to simulate traffic. Okay, so it's installing that, and to uh, make things more interesting or to create replicas, we have to pass the threshold of 50 from this query. So what we can do is we can send traffic hey hyphen hand 1000 hyphen c 200 2000 not sorry http curl no why this local host 3000. So by this you can simply understand that we have sent 1000 requests to our application. We can also check the same using this keyword from QL as well. I think let it be 2M. Okay, I think I forgot one thing. To make things more faster, to scrap the values so that Prometheus can scrap more details faster from the nodes. Let me edit the config map of Prometheus server. kubectl edit cm Prometheus server -n monitoring. I've already done the same thing in my last video as well, so nothing new here. So let me edit this, add it to 10 second, add it to 10 second. Okay, so I think now it should fetch the details uh, faster. Yeah, see, 1001. And the same, it should, uh, yeah. So here also you can see it's 1001. Apply this and it will be now stick, or we can easily monitor the traffic into the home page, and we don't have to edit it again and again or write queries again and again. Okay, let us check if it has autoscale or create more replicas of our application or not. No. So let us use watch flag here so that we can also check the things. And in our new tab, we will send more and more traffic to check the things. Hyphen C, HTTP, localhost 3000. Okay, so it has sent thousand of, sorry, 10,000 requests. Refresh this. Let us do 5 minutes. You can see refresh and insert this 3000. Yeah, it will reflect correct values. Has it, let us check. It has, no, it has not increased the pod as well. So this much traffic was not strong enough to create more replicas. So let us do one thing, increase number of requests. Let it be 1 lakh. So now it should. So here I think the Prometheus, I can see that it has modified the value, which is 20,952. And let us check what is the threshold value it has reached till this point. It's 971. Okay, so it must have increased. C. So it has increased the threshold value, and the pods are also been creating. Let me check my Grafana dashboard. Okay, so yeah, here you can see it's 71,548. I'm not sure like what are these values. Maybe these are also related to the query, but yeah, we can easily check. Refresh this. See, it's 85,861, 1 lakh 3,028. And okay, so hey has done its work. Let me check how many pods are there. One, two, three, four, five, six, seven, eight, nine, 10. So yeah, it has created the maximum number of pods which we have declared inside our scaled object manifest file, which was 10, and minimum is 1. Here also you can check maximum replica count should be 10 when the maximum traffic is has been reached to the application, and the minimum replica should be 1 always. Let us again check. So here you can see we are not sending more traffic. So the cooldown period by default of KEDA is 5 minutes. So to scale in our pod, it will take around 5 minutes. And after 5 minutes, it will terminate all the pods. Only one pod will be remaining, which will be running our application. And if again we get more traffic, then it will again scale out the pods. If you are familiar with Grafana, please you can definitely explain me like what the things are running behind in this dashboard, because I'm not sure like what is running here. means it is running fine according to the web request and with the synchronization with Prometheus, but I'm not sure like what are these values. Let me check again. Let us check more uh, form of data. We can check. I think this is only suitable for us because it is we are able to see the number of requests. Apply 4 minutes. Okay, so up till 4 minutes, so back 4 minutes, the percentage was 434. Damn, three. It is zero. Okay, because we are not sending the traffic. We have stopped sending traffic. So till 6 minutes, it was 289. So let us check. So I think we have to still wait for like maybe 2 or 3 minutes to decide autos to decide KEDA. If things are under control, then it has to scale in the application. We don't have to do anything. It will automatically terminate the pods based on the traffic, and this also resemble the same behavior of serverless architecture because whenever there is a spike in traffic, the pod or the application will spin up more replicas so that it can fulfill or handle the load of the users. And if no traffic is there, then it will simply turn down the resources, which is irrelevant or not required. So let us just wait for few minutes. So I hope you all get some knowledge like how the things work using KEDA because I have done more than two videos or I guess 3 4 videos are specifically for KEDA, including this one. So I hope I am able to explain you the things which you wanted or which is new to you so that you can have some kind of advantage uh, in the job hunt or the job market. Even though I am also learning along with you, so it's a win-win situation for both of us. So I'm not sure we have to wait too much. I think it should start scaling in. So here you can also increase the number of pods, number of uh, yeah. So here you can see it has started terminating the pods. So what I can see is it has terminating the pods step by step. So currently it has terminating three, then maybe three, next three, and accordingly it will terminate all the pods, and we will be just remaining with one pod, which we always wanted because this is what we have written inside our manifest. No traffic is currently solving by the application, so yeah, let me do this. Okay, terminating. Clear this. See, now only one pod is running, which we always wanted to behave. So yeah, this was all in this video. I hope I was able to make things more clear and explain you again like how KEDA works with the Prometheus scaler. And yeah, in the future video, I will be trying to improve my knowledge more on Grafana, because to be frank, I'm not sure like how the things work in Grafana with depth. So yeah, definitely I will also learning Grafana along in this journey. So thank you so much and have a nice day.